Good morning everyone. This is Ms. Sheetal Patil and today we'll discuss about stack data structure. In this we'll cover what is data structure, what is stack data structure, representation of stack data structure, basic operations on stack, applications of stack data structure, advantages and disadvantages of stack data structure. What is data structure? Data structure is a storage that is used to store and organize data. Data structures are the fundamental building blocks of computer programming. They define how data is organized, stored and manipulated within a program. Basically, data structure is divided into two types: primitive data structure and non-primitive data structure. Primitive data structures are built-in data structures, or we can say primary data structures, such as integer, float, character and pointer. Non-primitive data structures are the derived data structures, such as arrays, lists and files. Lists are again divided into two types: linear list such as stack and queue, non-linear list, graph and tree. What is stack? A stack is a linear data structure that follows last in first out or first in last out principle. A stack is an ordered list in which insertion and deletion can be done from the one end, known as top of the stack. So as shown in figure, this figure shows representation of stack data structure. To insert an element into the stack is known as push operation. To remove an element from the stack is known as pop operation. And top indicate topmost element of the stack. This figure shows some real life examples of stack, such as stack of coins, stack of plates, can of tennis balls and stack of books. We can represent stack data structure using array as well as using linked list. This figure shows representation of stack using array. Stack defined as struct stack int data size int top. This figure shows representation of stack using linked list. We can define structure of a node, struct node int data, node pointer next. This is known as self-referential structure. Implementation of stack using array. So in this, first of all, we have to initialize an array to represent the stack. Use the end of the array to represent the top of the stack. Implement push, that is add to end, pop, remove from the end, and pick operation to check end, ensuring to handle empty and full stack conditions. Basic operations on stack: push operation to insert an element into stack, pop operation to remove an element from the stack, top returns topmost element of the stack, isEmpty function. This function is used to return a true if stack is empty, else it returns false. IsFull operation returns true if the stack is full, else false. Size returns the size of the stack. Push operation: insert an element onto the stack. If stack is full, then it is said to be an overflow condition. Before pushing an element onto the stack, we check if stack is full. If stack is full, this can be checked with the help of this condition: top is equal to size minus 1. Then we can say that stack is overflow. we cannot insert element to the stack. If not, increment the value of top by 1, top is equal to top plus 1, and insert new value at the top position. The elements can be pushed into the stack till we reach the capacity of the stack. Next, this figure shows how pop operation add an element to the top of the stack. So consider initially your stack is empty and that can be represented by top is equal to -1. If the value of top is equal to -1, we can say that the stack is empty. The first element to be insert is 10. So we'll perform push operation on stack. So after pushing and 10 onto the stack, the value of top becomes 0. Okay. When we push 20, top becomes 1. After that push 30, top is equal to 2. Next push 40, now your top becomes 3. So algorithm for push operation, check if stack is full or not. If not, increment the value of top. Add an element to the stack at the new top index. Pop operation, remove an element from the stack. If stack is empty, then set underflow condition. So before popping the element from the stack, we check if stack is empty. If stack is empty, that can be checked with the help of top is equal to -1, then we can say stack is underflow. We cannot remove an element from the stack. Otherwise, we store the value at top, decrement the value of top by 1, top is equal to top -1 and return the stored top value. As shown in figure, pop operation remove the top element from the stack. Current condition of stack consists of 10, 20, 30 and 40 and the value of top is equal to 3. So this figure shows that stack is full. Now perform pop operation. The topmost element which is at position 3 is removed from the stack. Okay. Then next again perform pop operation. Again top will get increment. Okay. So once your top becomes -1, it means that your stack is empty. So the algorithm for pop operation is check if stack is empty or not. If not, return element at the top index. Decrement top index. Now pick operation. Your pick operation return the topmost element without removing it. Okay. Algorithm is check if stack is empty. If not, return the element at the top index, that is 40. Is empty operation. It returns true if stack is empty, else it returns false. Algorithm, check for the value of top in the stack. If the value of top is equal to -1, then stack is empty, so it returns true. Otherwise, stack is not empty, so it returns false. So as shown in figure, stack is full, stack is not empty, so in this case it will return false. In second condition, the value of top is equal to -1, this function, this returns true. Is full operation, returns true if stack is full, otherwise it returns false. Algorithm, to check for the value of top in the stack, if top is equal to size -1, then the stack is full, so it returns true, otherwise stack is not full, so it returns false. So as shown in figure, the size of stack is full and the size of stack is 4, it shows that the stack is full. In second figure, the value of top is equal to 3, so we can say that the stack is not full and this is full function returns false. Applications of stack, expression evaluation like infix expression, prefix expression, postfix expression. then recursion, depth first search, undo redo operations in text editor, backtracking, browser history, forward and backward navigation, function call management using Next is advantages of stack. Simplicity. Stack are simple and easy to understand data structure. Efficiency. Push and pop operations on a stack can be performed in constant time. Last in first out. Stack follows the last in first out principle. Next advantage is limited memory usage. Stack only need to store the elements that have been pushed onto them. Disadvantages of stack. Limited access. Elements in a stack can only be accessed from the top. Potential for overflow. If more elements are pushed onto a stack, then it can hold and overflow error will occur, resulting in loss of data. Not suitable for random access. Stack do not allow for random access to elements. Limited capacity. Stack have a fixed capacity. So these are the disadvantages of stack. Summary. So in this presentation we'll see stack follow last in first out. Essential operations like push, pop, pick is empty, is full, size. Applications in various domains. Advantages and disadvantages of stack. Thank you.